Good afternoon. I'm Jay Scott, editor of ASHRAE Journal. Thank you for joining us for today's webinar, part of the ASHRAE Journal Supplier Webinar Series, providing information to journal readers and others about products and technology of interest to industry professionals. ASHRAE does not review supplier webinar presentations. Belimo welcomes you to today's webinar, Replacing Life Safety Damper Actuators, Understanding Applications and Codes. Today's presenter is Larry Felker, the Fire and Smoke Senior Product Manager for Belimo Americas. He has specialized in actuators and dampers for 25 years and is co-author of Dampers and Airflow Control, ASHRAE Special Publications. Larry is a member of NFPA, ICC, and is a life member of ASHRAE, where he serves as a corresponding member for Technical Committee 1.4 Control Theory and Application and Technical Committee 5.6 Control of Fire and Smoke. And now we turn the presentation over to Larry. Thank you.
Hello. Subject is on the slide, and it's the applications and codes that tend to be the things that are most important to people. Here's my email address. There'll be questions, and you can certainly email me, and I'll answer to the best of my ability. Sometimes there are too many questions and for the time allotted, and sometimes they are a little bit complicated. Here's our agenda. So a little bit about smoke control, then the types of dampers, because there's definite confusion about that, and then what the codes, standards have to say about replacement, and then some of our technical information. This is an overview, so if anyone needs detailed things, they can let me know, and we could arrange a webinar. Fairly well known, smoke is the #1 killer in fires. We see it time after time, and with or without sprinklers. And of course, sprinklers will control fires very often, but smoke gets generated, and cool smoke actually produces a lot of cyanide compounds, which are just as dangerous as carbon monoxide. So it's a toxic smoke that is very important in keeping control. Dampers are installed per 2 chapters primarily in the International Building Code. Chapter 7 deals with structure, and compartmentation needs to be maintained in fire walls, barriers, and partitions, and smoke barriers and partitions. So the whole idea is if a fire starts in a zone, that we get dampers closed in the barrier walls so that we can contain both the fire and the smoke. The Chapter 9 of IBC, those applications are the engineered smoke control systems. So in the example shown here, stairwells, if there's a fire alarm in the building, the stairwell pressurization system is enabled, and a fan will keep pressure on floors, on their doors, so that smoke can't enter the stairwell. So here we're not trying to exhaust or contain, we're actually trying to prevent the movement of smoke. It's not a fire application. And about 15% of dampers installed are for an engineered smoke control system. The reason why it's important to distinguish between them is because the testing requirements are different for the 2 types of systems. Dampers are installed as part of a system, not just in themselves to protect the walls. And here are some of the aspects of the building which the dampers might be coordinated with. So it can get fairly complicated on the smoke control systems, as opposed to the Chapter 7 applications are simple. I'll let you read it rather than my lecturing. So dampers are part of a big system, and we could see things happen in buildings that with bioterrorism, gas or other toxic chemical leaks, any accidental or intentional fire, of course. And then we want to control smoke migration far from the origin of the fire. So we've got sensitive property, records, telecommunications equipment, possible water supply shortages, and the dampers are going to be backup or part of a whole system. We speak of it as balanced or layered fire smoke protection. And the number one enemy, and this has been chronic since I was a kid, deferred maintenance. And you can see a couple examples here. I got that picture on the right about a month ago, and I have a report that says that beer can top went out in the 1970s. I don't know for sure, but it's possible that beer can's been sitting in there for 30 years. But we see stuff like that. And it's why inspection and testing of dampers is important if we want protection. The types of dampers. There are sealing radiation dampers. So just about every diffuser in any drop sealing or ducted sealing is going to have a heat radiation damper above it, and we're going to keep, if a fire is in the space, we're going to keep heat from going up into the plenums and causing a problem. They're non-actuated, they're a fusible link, and there is no periodic testing required of these. They're pretty reliable. They're considered perfectly reliable as long as they're installed properly. Now, fire dampers. Most of them are fusible link. There's the curtain damper. If that link melts at 165 F, the accordion blades are going to drop into that hole or be pulled down by a spring, and they're going to prevent passage of fire. They're for Chapter 7 applications. There are alternate type. You can see multi-blade dampers, but they're not as common. So the curtain damper is the most common fire damper. Smoke dampers. These are always actuated. We have a mechanical way of measuring temperature, the fusible link, but we have only electronics for measuring smoke. So we're going to have a smoke detector. Might be part of an area smoke detection system or a local smoke detector. And we're going to have a smoke damper that will be actuated, and it will spring that damper closed. And then there's the combination fire and smoke. So we're going to have a temperature sensor. At the bottom below the actuator is a thermodisc. It's manual reset. And at 165 F, it will cut power to the actuator and spring it closed. And then there will be a smoke detector wired or a relay wired in series with the power going to that bimetal, and that will be what causes the smoke function to close the damper. So it's a combination. This is the most common wiring you're going to find in probably 85% of dampers out there. This is the wiring. So you've got a smoke detector there on the left, and mounted on the damper itself, you've got the thermodisc. So hot power goes through a contact, and as long as you don't have smoke, power is delivered to the temperature sensor. If you don't have high temperature, power goes to the actuator, it dries open, and it'll sit open for years at a time until tested. The damper itself is not connected to the fire alarm system, but codes do call for, if you've got a smoke detector in the building and there's an alarm system, then it's the smoke detector that will close the contact and alarm that there's probably a fire in the building. Smoke will be sensed long before the temperature rise. Now that's a Chapter 7 application. The Chapter 9 is going to be a lot more complicated. You could have a reopenable damper. They're not required. You're going to have position indication at the damper, and the firefighter smoke control panel will be able to override the damper, open or closed, or leave it in the automatic mode. So this right here would be a full smoke control system. And the graphics panel, the smoke control panel, and the fire alarm panel are often the same panel. Even in fairly large buildings, it'll be one big panel. As soon as you get to even larger, you're going to have a workstation, which isn't shown here. It may coordinate it between the temperature control functions, security, and the fire and smoke protection. New construction, the International Building Code and the International Fire Code are the model codes for everywhere in the United States. And they specify that the fire dampers will be UL 555, smoke dampers 555S, and those ceiling radiation dampers 555C. This is the new construction, and those dampers have to have been tested to these standards. They're factory standards, so you will test the dampers, and the damper manufacturers will provide installation methods for the different construction, as well as regulating the factory construction, what actuators are allowed. Once installed, periodic inspection and repair is mandated by the two codes to use the NFPA standards, standards 80 and 105. Those are the governing standards for periodic inspection and repair. UL 555 is not involved in the field repair once those dampers have been installed. So we wanted to stay between Chapter 7 and Chapter 9 so we can look at the periodic inspection requirements. On the left there, it's Chapter 7. It's a simple smoke detector in the duct or a relay, and the fire smoke damper in a barrier. On the right side, we see at Chapter 9, we're going to have connections to the firefighter smoke control system panel. Those are the two major differences. So then the periodic testing requirements. Chapter 7, essentially every 4 years, except in hospitals every 6 years. Chapter 9 systems are going to have to be tested at commissioning, but then semi-annually if it's a dedicated control system, or if it's non-dedicated, in other words, the equipment is used for some HVAC or exhaust function, then once a year. And then the Chapter 9 systems for any fire detection and the smoke control systems themselves have to go through a weekly self-test. Now that, if you read the codes, it would include the dampers. The whole system has to be tested, but there's an exception. If testing the dampers could cause some problem in the building, either mechanical or interfere with operations, then there is an exception that's allowed. I'm not going to go into that part of the codes here. So here's the summary. I'll let you read it. So the bottom line is the codes require periodic testing. And both NFPA 80 and 105 are very clear. It's not that you are allowed to repair dampers, you are required to repair dampers. And it's the building owner's responsibility. It's not the fire department, it's not the contractors. Owners are responsible for the periodic testing. Now, of course, they could have their own people doing it. More likely they're going to have a TAB contractor or a dedicated testing service look at all the dampers. And they have to fill out a logbook just saying they've tested each damper. Now, what are the standards and codes about replacement? Here's what UL says. This is a guide. It's not a code or a standard. It's part of their marking guide, but essentially, part of smoke damper actuators, the dampers and the actuators, are not covered by UL or regulated by UL once installed. That these are appliances and can do field servicing. You've got to do field servicing if you're going to follow the codes. Now, AMCA, the Air Movement and Control Association, which is the damper manufacturers group, does have a guide for periodic testing. And the testing is rather straightforward and clear. Observe that it's open. Well, those defective ones we saw in the first pictures were open, but they were being blocked. The damper has to spring or drive to the opposite position. On some of your Chapter 9 dampers, they are normally closed and have to drive open, but 90% of what is out there is driven open and spring closed. So we got to observe the damper closes and then observe that it opens again to the correct position and correct any deficiencies. It's very, very clear and simple. Here's what the standards say. You don't have to replace the damper as long as it's in good enough condition to serve, but you got to fix it right away. And there's the IFC section, which is the fire code is the most important here for repair and maintenance. Section 706.1 states that you should do it in accordance with NFPA 80 and 105. So replacement. Damper sizes out there in the market, fully 50% of them are less than 2 square feet. So you're looking at small dampers, small actuators. Some of them are a pain in the neck to get to. About 30% are between 2 and 4 square. So fully 80% of dampers out there are relatively small, less than 4 square feet or less. And about 10% are 4 to the 12 square feet, and about 10% are big dampers. We pay a lot of attention to the big dampers, but the mass numbers of them out there are rather small. Whenever you're looking at repair replacement of a damper, you start with the damper, not the actuator. So you don't simply replace an actuator. You got to look at how the damper worked, particularly the old ones. And I'll show you a couple more examples here. When people want us to help them, no problem. We do a lot of it every day. Digital pictures are really helpful. About 80% of the dampers are quite straightforward, but about 20% of them are weird and bear some investigation. This is actually the same model actuator as we were just looking at, just a newer application. Notice the orange arrow. That's the spring that closes the damper. The motor there is a non-spring motor, even though it looks like several makes of spring motors. So when you're going to go replace that motor, you've got to disable that spring because all the modern actuators have internal springs. So you're not just replacing that motor, you're also going to be loosening that spring because now you're going to have an internal spring that takes care of it. And that brings it up to the modern UL 555 method. So I focus on the spring method whenever I'm working with anyone to do a replacement. And as I said, 80% of them are straightforward, 20% are real old and weird. Here's a CB MA220. That's a non-spring motor. So when you go to replace that motor, you're going to have to disable that old spring. And all it amounts to is 2 bolts and a screw that loosens it, and you get the spring off of there, and then you can mount the new motor. So it ends up looking like this. So the replacement's straightforward. Here's a common application. Well, you don't worry about the motor itself. You look at the damper shaft, and you can see readily that you can direct couple a BLEMO over that damper shaft. So you're looking for the damper shaft, and you want to make sure that all the controls are the same. Here's one, it's a non-spring motor, but the spring is quite obviously visible. So replacement's going to be fairly straightforward. You're going to remove the spring cover and the old motor. It's only a 2-wire application, and you're going to drop a new actuator right over the damper shaft. So you're not replacing only the motor, you're replacing the motor and the spring. Here's a case where you don't try to replace that motor and use a linkage. You're going to direct couple over the damper shaft. So it's the same theme repeated over and over. You just got to take a look at it. You are going to be careful not to remove the bearings. So there is a bearing underneath that curved linkage. Well, you're not going to remove that. Notice the spring on the damper shaft, top left of the picture. There's a fusible link there that's holding that arm back, and if it melts, that jack shaft spring will slam those blades closed. So that's the fire function. The smoke closing function is the motor. So you're going to leave that fire fusible link and spring alone. Those don't get changed. So this dual springs is very common on older dampers. On the left side there's a fusible link and a spring. You don't touch it. On the right side, you've got an old motor, but we're not going to try to replace just the motor. The spring is on the motor shaft, and there's an arrow pointing to it. You're going to go for the damper shaft, which is on the right side. So you're just going to remove all the old linkage and motor and direct couple to that damper shaft. So on the left side there, you've got a motor. You can't see it. It's hidden underneath that sheet metal piece. You've got a spring, a housing, linkage. You just get rid of all of it. And when you go to the right picture, you're going to see that we've direct coupled right over the damper shaft. That's the way the modern dampers are handled. In this case, we had a very short shaft, so we put the clamp internally. You can see the old motor, its shaft is sticking out above the Belimo. That old motor made a nice platform for mounting the anti-rotation strap, so we didn't bother to remove the motor. We probably should have hacksawed the shaft off to make it look better, but that's not a functional part. So the single spring was another method used. It's different. You're going to have to replace the fusible link on the damper and disengage that old spring. And then when you put a spring return motor in, you're going to have to put in a new temperature sensor. So there's a manufacturer's part number there. You can use ours or the manufacturer's, but you got to put in a new thermodisc. Here was an old Phillips motor. That's that first picture I showed. The motor's non-spring. So that arrow over on the right picture shows where the spring is on the old damper. So that motor has to be replaced with a spring return motor, same linkage parts, and then you've got to disable that spring that's on the damper. When I first looked at this one, it was in pretty bad shape, and I said, why don't we replace the damper? And the fire marshal had already approved it, and everything worked fine. But when you look at some of these old ones, you wonder. Negator spring dampers were quite different. That spring that shows there is connected to the damper blade itself, and it pulls that damper closed. And there is a fusible rod instead of a fusible link that connects between the crank arm on the jack shaft and the damper blade. These parts are no longer available. The dampers were very solid and quite functional. It's just that you've got to replace all the parts with modern parts. And we have a full instruction showing just how to do it. The pneumatics are much easier, and the damper manufacturer does have a kit for mounting an actuator externally. Typical retrofit instructions. We have instructions on our website. It's www.belimo.us/firesmoke, and it goes by the damper manufacturer with different actuators. We've got instructions for all of those that we've bumped into over the last 20 years. So you can get a specific instruction. The instructions themselves have the UL statement, the code and standard issues, what NFPA 80 and 105 say, and then it goes through the technical requirements, the cross-reference for the motors, and the last page of it is always a form that you can fill out for testing, and then leave it in the building per NFPA 80 and 105 so that you can meet the code requirement that logbook or record is kept. But both NFPA and or 80 and NFPA 105 require the logbook or record be kept. Some cities have overridden it, just simply saying you got to keep a copy of the invoice. Chicago, for instance, that's the rule. Keep a copy of the invoice in the building for any changes you've made. I've got 3 other classes that I run commonly, so if anyone wants me to set up some webinar, our people can do that. But I have one that goes through details of a lot of those dampers and the replacements, and then another one that covers only the standards and codes, and then another that's our product overview. Product is the easiest part of all of this, and torque is the least of the things that we have to worry about. We know what the UL 555 requirements are. It's typically mounting in whether you need to put in a new sensor or not. So the replacement is a rather straightforward issue once you know what you're looking at. So it's time for questions.
All right, thanks, Larry. Hey, everybody, my name is Frank DiPaolo, and I'll be helping with the questions and answers part of the webinar. Larry, we have a couple questions when you are ready.
I'm ready.
All right. First question is, how do you test that damper is closed if they have a fusible link?
The multi-blade damper, fire smoke damper, that fusible link is holding the blades back, so it's not. You can drive the shaft open and close with the actuator, and the shaft spring won't affect anything. It is not required that you remove the link and test it. So therefore, you only exercise the actuator, and assuming it was normally driven open, you simply spring it closed and drive it back open. Prove that it operates. I hope that answers it. Now, if it were a curtain damper, then you should, and I'd have to go check the AMCA guide because I don't remember, since it's not actuated, I don't deal with them often. I would loosen the fusible link and ensure that the blades drop down or will get pulled down by their spring, and then reopen it and reattach the fusible link.
Great. From a commissioning agent standpoint, how should they be tested when initially installed?
It would be the same. Assuming we have a Chapter 7 normally open damper, we're going to cut power, spring it closed, and then drive it back open. One of the pains in the neck about that is that the codes don't require any kind of a switch. Most states' codes don't require any kind of a test switch. There are momentary switches available from the damper manufacturers. I highly recommend them, but it's not code required. Then you have to go open a junction box and cut power, or you can go to the bimetal. I think that answers the question. You got to cut power, spring it closed, and reconnect power. Just how to do that varies.
Right. How do you determine what actuator to replace on a damper if the existing one is not available?
Most of the existing ones are not available, so all we do is use the UL 555 test data. So we know that actuator FSTF handled 1.5 square feet. Therefore, we have that in our installation instructions. We don't give out the data from the damper manufacturer who got the largest one tested. We use the minimum so that we're being conservative on torque. Very often, we don't know what velocity they were working at, whether the damper is corroded or has possibly racked a little bit or twisted. But we make an assumption that the damper is properly seated in the ductor wall. We just use the UL 555 data.
When you replace an actuator, not a like kind on a damper, that is older than 2002, previous UL 555 standard, the building owner will ask, is the damper still UL approved? What do you tell them?
It is not, strictly speaking, UL approved. First off, it's up to the local AHJ to say whether that's required or not. If you bring it up to the modern UL 555S standards, that is 95% of the jobs I've done, that's what the inspectors want. But you have replaced it with an actuator, and UL does not keep the old procedures. So there is no procedure that covers that damper. But they will send, if you want to get to their field service people, they will send somebody out to confirm that it is done as the new one would be done. They won't put a label on it, but they will give them a letter. And if a building owner wanted to, they could replace every damper and bring them up to totally new standards. It's not required by codes.
What qualifications are required for people inspecting life safety dampers?
It varies by local jurisdiction. There are a few states and cities that have a requirement for an ANSI certified tech. More often, anyone can do it. And given the simplicity of course, most dampers, that's not a problem. But it does vary by jurisdiction.
What is the service life of new style actuators?
Varies by manufacturer. We started selling our current ones in 2002, and we do not have a replacement market yet. So let's say we're looking at 15 to 20 years.
It was my understanding fire and smoke dampers are considered UL listed assemblies, which are not allowed to be modified in the field. I understood this to include replacement of actuators. Have you heard this before?
I have heard it frequently, but it is not the case. The UL certified products, as UL said in that one statement I showed, you can replace actuators. Now that's according to UL, because they don't have jurisdiction over installed product. Your local fire marshal or building official are the ones who have jurisdiction. And NFPA 80 and 105 require that you repair them. You can replace them, but you can repair them. And replacing actuators is very common. Any more questions, Frank? I think he hung up on us. I've lost sound. I don't know if you... Aha! We lost Frank. I don't get to see the questions. Frank is the only one who reads them off to me. So I'm going to go back to the beginning of this presentation, and I would like anyone who has questions to shoot me an email. Sorry, I'm not used to working on their systems, so I have to go back slide by slide. And of course, I have no idea whether you can hear me or not. There's my email address. Oh, I'm supposed to be able to open a window here and look at the questions and answers. We have time, so I'm going to pop them open.
Larry?
Ah, there you are.
Hey, sorry, we had a little technical difficulty. We'll continue. Do you recommend to replace the whole fire damper if it fails to close after the fuse is removed, or just lubrication would be enough?
You know, that's a good question. It's impossible for me to say without having touched the thing myself. I have recommended the replacement of many dampers. They're in terrible shape, and they should, you know, I don't want to believe an actuator on there. So if you got a damper that's in sad shape, replace the whole damper. That's easier said than done in some cases. I think the worst case I saw was $12,000 to replace the damper. We had asbestos in the way, drywall covering it. We couldn't get it in from the mechanical room side. Work had to be done at night with a containment hood. So it can be awfully expensive to replace a whole damper. And you could have a functioning system with just the actuator. But I would try the lubrication, and I would check the fusible link. If it's a curtain damper, it's really up to the damper manufacturer to advise. We don't get involved in the curtain ones at all, or even in the multi-blade fire only.
All right. How familiar are you with fire and smoke damper applications in the marine environment? Would you be willing to set up a seminar on the subject or point me in the right direction?
If they emailed me, I would point them to the damper manufacturers, because the marine applications are not something we get involved in other than providing actuators. And they are regulated by either the U.S. Coast Guard or the insurance company. So it's not something that I feel highly qualified about. But I could put them in contact with a few people who do that.
Radiation damper is only needed where the ceiling is part of the fire-resistive assembly, right? In other words, if there is a concrete slab that provides the full fire resistance, I don't need a radiation damper, correct?
You've now moved beyond my area of expertise. They're non-actuated, and I don't deal with them. And that's a question for a code consultant or the damper manufacturers. The damper reps should be able to answer that. I don't know.
Is the power to damper given all the time during normal scenario?
Yes. Oftentimes the actuator is connected directly to a breaker, and it will be open 100% of the time. Sometimes it's powered off of a contactor for a fan, so it'll only open when the fan goes on. And sometimes it might be on the smoke control system where it is closed when the fan is not in operation. But I would say 70% of what I've seen, they're powered all the time.
Can you talk about the pros and cons of remote testing of dampers, e.g. via BMS?
Yeah. Remote testing is now allowed by NFPA AD in 105. And there is another NFPA committee looking at remote inspections in general. And it will probably have some periodic testing chapter or annex in it. The method, whether it's done by the fire alarm panel, which right now probably 90% are, or versus the automation system, it wouldn't matter which was done. Where remote testing is quite valuable is on those dampers that are nearly inaccessible. And I've had to crawl over ducts and down and to get to a damper, and that's a terrible place to put a damper. But space constraints can be pretty severe, so that's a good place to put remote testing. If they wanted to copy one of my articles on remote testing, they could email me. It's sort of a long subject.
As replacement actuators are not covered in a manufacturer UL certification, who takes responsibility for the install of a new actuator?
The installing contractor or the building owner.
All right.
Note that there's never once been a lawsuit regarding the subject, so it is not a high risk as long as you make sure they're installed correctly and you test them so they work. It's more of a liability to not replace the actuator and leave the damper fastened open. Then,
how many fire dampers should be per floor or square foot in any kind of commercial building?
There's no rules. It's a matter of the wall. How many walls do you have? How many ducts are passing through walls? But there's no code rule.
Is there a qualification for people that work on and replace these actuators on existing dampers? Can anyone do it, whether trained or not?
If they're not trained, no. They shouldn't be touching them. Is there a code requirement? Not everywhere. However, it only stands to reason that you want qualified people working on your building and doing any of this. The TAB contractors or the shuttle contractors are the best people to have working on it. But this is something I could have an opinion about, but I have no official capacity to speak on that. It stands to reason you want qualified people doing things.
Right.
Sorry,
what labeling is required for fire and smoke dampers as far as for locating above ceilings and such, and does this apply to through the grill accessible fire and smoke dampers? Where would you place the labels?
The codes have a requirement that if you've got a damper, say above a drop ceiling, that you put a label there. But I'd have to go look at the codes. But it is required. Do people obey it? No.
Have you heard of any issues with owner's insurance since they often require UL listing?
No, because I go to the local AHJ, submit a copy of the instruction, and they're the ones who actually approve a replacement. And we are oftentimes bringing them up to the current UL. We're putting in a current UL actuator instead of an old one that wouldn't pass today's UL. And since it was broken, we're bringing it, we're making them work again. But I go to the local AHJ. I do not go to UL. UL does not regulate field installations.
What are typical lifetimes you see for both fire dampers and fire smoke dampers? Or when should you be looking to replace them?
I don't know if there is a typical. There's probably stuff that was installed 5 years ago that ought to be fixed. I've seen a 1930 fire damper working just fine in Rockefeller Center. I was up there changing fusible links with a technician. And we've seen combination fire smoke dampers very solidly made from 1975 that are the motors were defective, but the dampers were in great shape.
And as a follow-up to that, what is the main difference between fire dampers and fire smoke dampers?
Oh, well, the fire damper is tested for flame passage. So it's actually fire on one side of it, and it has to maintain its integrity and the integrity of the wall under fire conditions. A smoke damper is tested for passage of smoke. So a fire damper will pass a lot of smoke, but no flames. A smoke damper could let flames through, but it'll stop smoke better. The combination will do both.
All right. Removal of the linkage is mentioned in actuator replacement. Is it a code requirement or just a good to have when space is not a concern?
I don't understand. Would you say that again?
Removal of the linkage is mentioned in actuator replacement. Is it a code requirement or just good to have when space is not a concern?
I don't understand the question exactly. There is no code requirement to remove linkage or to have linkages. They don't matter. All of the modern fire smoke dampers are direct coupled actuators on the jack shaft, and that is the accepted method today. But on those old dampers, there's no need to keep the linkage. It's something extra that can break, although we don't see too much trouble there. So if I can direct couple, I'm going to remove the linkage, and I'm going to direct couple. If they had any pictures or something of a project, I'd be happy to look at it if they emailed me.
Are dampers always in HVAC ducts?
No, sometimes they're in a wall, an air transfer opening. You'll also see the rolling fire doors over some big openings.
Are the European fire smoke models such as BFL model meet the requirements of UL 555 and UL 555S? If not, what is the difference comparing the fire and smoke series?
That's a hard question. I don't know. They're quite different construction. They're tested to a lower actuator temperature, but they actually put a higher temperature on one side of the damper. The blades are like a calcium carbonate in some cases, but I don't think anyone has ever taken any of those dampers and tested them to UL 555, or if they have, I hope one of the damper manufacturers mentions it to me.
We have time for a couple more questions, and we'll do a last call for questions as well. Is it a usual requirement for power for the smoke dampers to be on backup generator power?
If they're in the engineered smoke control system applications, yes.
Does the local AHJ have to come back out and inspect the damper after an actuator has been replaced?
No. And the permitting rules vary. However, actuator replacement is considered to be a normal repair in most cases. Even California, Northern California, I've worked with those guys a lot and with the inspectors, and they want that NFPA 80 and 105 logbook maintained. but there is no permit requirement. And the fire marshals don't have the time to be going out to 4 million installed actuators that need to be replaced over the next 20 years. They don't have the manpower. It's the building owner's responsibility.
One last question before we close it out. Are fire dampers can be tested to UL 555 with general application actuators such as TF series, not FSTF?
No, they wouldn't pass. The elevated temperature, 250, would kill most actuators.
All right. Thank you so much, Larry. For those questions that we didn't get to, we will try to after the webinar.
Thank you, everyone.